Hey everybody, how's it going? So here we have an A1502 MacBook Pro. I think I have an idea why this thing is not turning on already. It seems to have a GoPro sticker on it. I did a review of the GoPro Hero 7. This device takes over 27 minutes to set up a single live stream on. You can see that if you search for the GoPro on my channel. So that being said, let's open this thing up and see what's going on the bottom of the machine. We're going to open this thing up and see what's going on. I'm going to do this quickly so that I can get home soon. So when we plug it in, we get no green light, and it looks like no amperage taken. It's taking no amps. So let's take the board out of the case and try to get an idea of why it's taking no amperage now, shall we? Okay, so the first thing we can see here is there's minor corrosion by the PP3V42_G3 hot circuit. And if you watch any of my videos on the one-wire circuit, which was required for the machine to speak to the charger so that the charger light turns green, you'll know that that's powered by PP3V42_G3 hot, which is the rail that has corrosion over here. Secondly, we have corrosion on the actual one-wire circuit itself. These are the two chips that are going to control dealing with the charger. This chip speaks to the charger, and this chip allows the SMC to speak to the charger. So the SMC, System Management Controller, right over here, is going to speak to the charger through this IC, but this IC has to power that one on, and also we have corrosion by the ISL6259, so we kind of have a triple whammy here. So let's go through this board and just see if I can show you on the screen what it is that's causing these problems. So we can open up the board view in the schematic for an 820-3476, and let's get to work. So, first things first, what do I mean by the charger speaking to the machine? Let's open up this charge port over here. That's the charge port. See right over here. If you look on the desk, see, charge port connects to that. So that's why I'm clicking this on the schematic and board view, J7000. Now J7000 is going to bring me here. We have 18 volts, we have ground, and we have adapter sense. Adapter sense is going to be responsible for sensing the adapter. This is not like a normal charger that just sends out 18 volts for the hell of it. It needs to be told to turn on. And if you take a look over here at U7000, U7000 is going to sit between the charger and sys1 wire. Sys1 wire is going to be a line that goes to the system management controller, where the SMC is going to speak to the charger. Now, for this chip to turn on, it needs to get its VCC voltage. VCC at the top of a chip pin is going to mean power it needs to turn on. Same thing for just about anything, like my microscope here. See, this is my microscope camera, right? This is my video HDMI cable. This is my power. So this would be considered the VCC pin of my microscope, just to make things easy and oversimplified there. So when you see that on the chip, usually, especially when it's on the top of the chip, that means that's what's going to power it, get it to turn on. Now, it gets that power from this chip. And this chip gets its power from PP3V42. This is a logic gate. If you Google this number, you'll see it's a logic gate. And the way this works is when you have A and B, you get Y. I would zoom in more, but Paul Daniels' software doesn't allow you to, possibly because I have the old version back when it only cost $60 or $80, rather than the new version, which costs, I don't know, a Bitcoin or something like that. So SMC BCOK has to be present, and when that's present, it's going to take PP3V42_G3 hot and pass it on to this chip. Now, U7000, if you take a look on the board, is going to be over here. The very chip that is corroded. See? Corroded. Right there. Now, the next thing over here that we have a problem with is that PP3V42_G3 hot is going to be powering this chip, and PP3V42_G3 hot is created by this chip down here, U7090, and U7090 also has corrosion on it. So we have multiple things that could be going on here. We could be missing PP3V42_G3 hot, or it could be that our one-wire chip is bad. So let's use our multimeter by turning on the amazing Paul Daniels software. And by the way, if you want any of Paul Daniels' amazing software, you can find it on pldaniels.com. That's pldaniels.com. And we're going to see if PP304.2_G3 hot is present. So what do we get? Well, the first thing that I notice, there we go. Here we go. PP304.2_G3 hot is indeed present. However, we don't get a green light. And I imagine a big part of that is because the one-wire chip circuit is in itself corroded and nasty. Also, so is this over here. This is going to be what creates SMC-BC-ACOK right down here. So this chip is where SMC-BC-ACOK is going to be coming from. If we look on the schematic in the board view, remember what I said here? This is going to be a logic gate that allows voltage to flow through to this chip that allows the charger to speak to the machine if SMC-BC-ACOK is present. And SMC-BC-ACOK can be pulled down by this chip that has a bunch of corrosion by it. So now what I do here, what I do when I have donor boards, this is the reason I love donor boards. These rechargeable batteries really suck. Okay, so we're going to go back there. So, rewind due to the shitty mic batteries. So, what is... Now, I'm not going to spend time to figure out exactly which one of those interrelated chips is bad. Is it PP304.2_G3 hot chip not being corroded that is the problem? Is it the one-wire circuit chips being corroded that's the problem? Is it the chip that is going to pull down SMC-BC-ACOK that's the problem? Honestly, I don't care. This is why I like donor boards, because I can get donor boards very cheaply, and then I can just say, you know what? It's going to replace all three at once. And the other thing I like about having donor boards is I don't have to go, what's the value of this resistor? What's the value of that capacitor? What's the value of this resistor? What's the value of that capacitor? And then flip through a book over and over again to try and figure out, you know, go through one by one and replace each one. It's just, it's too much work. And if I can get a donor board that hasn't seen much, if not any use, and I can simply replace these pieces quickly, that means I can get more repairs done for customers, which means more faster turnaround time, which means less pissed off clients, which is something that I think is important to understand, that there's a practical element as to why I do things the way that I do them. So let's get back to the board and put my fume extractor on and replace these things and hope that the AA rechargeable batteries don't die again. I'm probably going to wind up shooting my batteries with a BB gun before I move. Now remember, we actually have PP304.2_G3 hot. So this, I'm probably just going to replace the nasty capacitor, but I'm not going to replace that chip just because of one little flake over there. So I do this. To the person who asked if Apple is still shredding boards, I'm not sure if they are still shredding boards. I would suggest emailing Tim Cook and asking what his policy is on the matter. Okay. Now, if I had to guess which of those individual components was the one that was actually responsible for this death, I would say that it is going to be the small transistor that powers the small logic gate that powers U7000. So not the chip that deals with the speaking to the charger, but the chip that powers the chip that speaks to the charger. And the reason I say that is because of how disgusting its pads are. So this pad is entirely off the board. But still, I'm replacing the other things because they saw enough liquid damage and they're important enough that I don't trust it after seeing a lot of liquid. I also want to prevent this from coming back for warranty. As any good repair shop says, and not in the rude way, to their customers as they're leaving, I hope I never see you again. So this is bada bing. Make sure you're not soldering on top of corrosion, so just a little bit of pad scraping there, and there we go. And down here, same concept. So, too much solder on the center pad is my trademark. That's my signature move. It's my finisher. And looks like nothing is changing today. Alright, we just... Okay, now we're going to use the hot air station, take some stuff off of my happy little donor board over here, and then this board's going to have a little happy green light on it. And above all, a happy customer that didn't have to buy a new board because of Apple. And that's that. At the end of the day, the thing that makes this job worth it. The thing that makes the job worth it. Whether it's dealing with contractors or realtors or attorneys or aggravating business nonsense, bankers. You know what makes it worth it? The smile that you see on someone's face when you hand them back something they thought they destroyed and that they wrote off entirely. When you're able to give somebody back something that they had written off and said, you know what? I guess I just can't have that anymore. I accept that it's gone. And nope, it's not gone. Right over here. Here's all your data. Here's all your stuff. And you have to pay less than you thought. It's a happy feeling. And it makes it worth it. And if you think about that level of positivity, then that chip that tried to run away from the board will be found before it falls into the air filter. Or did I speak too soon? I spoke too soon. But that's fine. That's why you have secondary donor boards. That chip is really fast. That chip ran off the board faster than Oreo jumped on the counter after he got his new supplements. By the way, everybody, you know who's right next to me right now? The man that refused to pet the kitty. Remember that video where there's this guy just sitting and smirking as his little kitty is begging and screaming as loud as he can, please pay attention to me. Please pay attention to me. And this evil man ignores him? Here's the evil man. And one of you commented in that video, I hope he gets hit by a truck. And that was indeed too soon. Too soon. Did you see about the march against anti-Semitism today across the Brooklyn Bridge? I did not. I avoid the Brooklyn Bridge on a regular basis because it has a bunch of tourists that don't understand the concept of a bike lane. Just look at some videos from New York City about people riding the bike over the Brooklyn Bridge. It will raise your blood pressure. And what I do to keep my blood pressure from being raised is I don't take the Brooklyn Bridge unless every other bridge is closed. Okay. You see all that solder I put on the center pad that doesn't belong there? That's my signature. Every artist needs their signature, and that's mine. Excessive solder on the center pad. Some people never change. Add some flux and touch it all up, make it look nice and pretty. Nice and pretty. I'm not usually a hot tweezers fan, but this'll do. A little bent. I suppose I could. Beautiful. My LED protector for the microscope just fell off. That's what protects my LEDs from getting burned. Check it out. Wait a second. Damn it. You go up here. Technically it's the same. Maybe the same place. Yeah, there we go. That looks more like it. Alright. Don't know what you're talking about, Terry. Why are you trying to run away? Okay, now we've replaced the ISL6259, which can pull SMCB CACOK down. We have replaced the nasty capacitors by the PP342_G3 hot circuit. And we have also replaced, most importantly, the one-wire circuit component that was corroded. if you look on the schematic and the board view, you'll see that the nastiest section was the PP342_G3 hot pin of U7001, so most likely this chip could not pass 3.42 volts onto here because the PP342_G3 hot pin was corroded, therefore it wasn't making its way to here. So we've replaced that, and I'm fairly confident this is going to turn on and work now, but also confident that it's going to last into the future since we replaced all the ancillary components that were also somewhat damaged. So let's see what happens. Let's see if this actually turns on and takes some amperage. We should be seeing 400 to 500 milliamps of usage over here and see a happy little fan spin. Do you think we'll get a happy little fan spin? Oh, well then. We got a happy little... Okay, we got a little bit of happy magic smoke there, but that's fine. That's just a little detour. Little detour on the way. We just do a little bit of this, a little bit of this, and we'll just pretend that that didn't happen. And a little bit of this, a little bit of that, bada bing, bada boom, and that magic smoke is going to go right back in the wire where it belongs. So this, yeah, that's no big deal. All right, we try it again. 1, 2, 3, bada bing, bada boom, and fan spin. You heard that though, right? No. So that's about it for today. I hope that explanation was helpful. I hope you kind of have an idea as to how what my approach is, why it is I do things the way I do, why I prefer to use donor boards than replace a bunch of individual components one by one by one, why I prefer to do failure analysis after the fact rather than in the middle of the job, because then you don't get the job done. If I just so happen to figure out or I get a guess as to exactly what caused the failure, that's fine, but that's not the customer's priority. The customer will want to know exactly what it is, but if I tell them 3 chips versus 1 chip and 1 trace, that doesn't matter. What matters to the customer is that we get this back to them as quickly as possible and for less than the Apple Store, which I believe we did here. So thank you very much for watching. I hope you learned something, and I will see you in the next video.